Professor Bob Young back at you here, and in this instructional video we're going to solve logarithmic equations. So in the previous video we worked on exponential equations, so it's only fair that we work on its inverse function, the log. So here's the first logarithmic equation we're going to look at. Solve the log, now this is of course base 10 since there's no base given, the log of x plus 6 base 10 minus the log base 10 of x plus 2 equals the log of base 10 of x. All right, now when we look at this one here, we've got two logs being subtracted in blue. All right, so whenever you see two logs being subtracted like that, we could combine them into one log by using the second log rule number 2. So we get the log of x plus 6 divided by x plus 2 here equals the log of x. Now, the next thing we want to look at is there's a little rule we looked at a while back, and it said this: if the log of any base number x equals the log of that same base number y, then x equals y. All right, so if you've got the log and it's the same base, in this case 10, of something equal to the log of something base 10 of something else over here, then since you have log equals log, you can just take whatever's after the first one, set it equal to whatever's after the second one, and then solve. So what they did next is they multiplied through by the common denominator here of x plus 2. So we'll multiply both sides by the LCD and do some chop. Well, the x plus 2's go out on the left, leaving us with x plus 6 times x plus 2. All right, distributing, we get x squared plus 2x equals x plus 6. And here's a nice little quadratic equation. As we get closer to the exam time here, we want to get the items equal to 0 and keep that x squared positive. So we'll go ahead and we'll subtract an x from both sides, and we'll subtract a 6 from both sides, and we'll rewrite this with all the variables on the left to make it prettier, and we'll get x squared plus x minus 6 equals 0. Factoring will give us x plus 3 times x minus 2 equals 0. So our two answers would be 3 negative 3, or positive 2. Now, when you check these, what happens if you put, I'll go up top here, a negative 3 in here? You get a negative 3 plus 2. You get the log of something negative. You can put negative 3 in over here, too. You get the log of something negative. Cannot happen, ladies and gentlemen. So you must throw out, this answer is called an extraneous solution. You cannot have negative 3 as the answer because you cannot have a negative logarithm. The domain must be positive. So that only leaves us with 2. And if you want to check that, you can. You will get that answer. If you plug 2 in here for x, you'll get, try this on your calculator. The log of 2 plus 6 is 8, okay, minus the log, and I hope I don't run off the screen here, of 2 plus 2 would be 4, equals, I'll come down here, the log of 2. So it should, and you should kind of think about this. You don't even need your calculator to check it if you know your log rules, because up top here, if you subtract 2 logs, you can rewrite that as the log of 8 over 4. And ladies and gentlemen, whoop, there it is. Just using your log rules. So you don't always need a calculator to check some of these if you know your stuff. And again, here's the caution flag. Remember that when you're solving logarithmic equations, the domain of the log is 0 to infinity, and you cannot even have the log of 0. Can't include 0. It must be positive. So it's always necessary to check and make sure that you get positive numbers for logs or natural logs. What? You want to try another one? Okay. Solve this logarithmic equation. So notice this one has a plus sign between the logs. So I'm looking here maybe at log rule number 1. If I see an addition sign between 2 logs, I can rewrite that as multiplication. All right. Now, also here, they went ahead and changed 1, since this is a base 10 number, into the log of 10. Now, a lot of students may not have seen this before. All right. So they tried to get it into log equals log, which in this case you can do, but not always can you do. So what I want to do is, skip ahead a little bit. Now, here's what's going to happen when you get down to it. You're going to have to use the quadratic formula here because you're going to end up with this quadratic equation. I want to show you a little bit better way I like to do these here. And then you'll have to let A be 3, B be -1, and C be -12, and plug it in our formula. Do y'all remember it? It's going to be on the final. Minus B plus or minus the square root. So you might need a little more practice on this. So isn't that nice? So we're just throwing you a little more practice here all over 2A. And then you will get these answers here. You'll get 1 minus the square root of 145 over 6 is negative. So x minus 1 is negative, therefore it can't be defined. And the other one is 1 plus the square root of 145 over 6. Now that one works because even one like that, you must take and plug in up here for x's. See, so when you do that using the quadratic formula, you're going to get this beastie looking thing. Now, I would never do this to y'all on a real test here or even the final. I wouldn't give you one like that. But I think it's pretty good here on the videos that we challenge y'all and say, hey, man, if that one's negative, that's going to be negative and it's not going to work in here. Throw it out. Only the plus side works on the plus or minus. All right, now here's the way I would have told you to do this one. Let's go ahead here. I would have said, once you use this first log rule here, and this works for all, the one that we had earlier worked with the base 10s, but this will work with any base number here. All right, so use log rule number 1 and rewrite the addition as multiplication. And then, ladies and gentlemen, I'm getting the clown face out. You ready? We haven't seen the clown face in a while. We are going to rewrite this in exponential form. Look at that. It's smiling at you. So this base 10 over here raised to this first power will give you what's after the log. What do y'all think? I like the clown face on that one better than try to get this 1 to be a log base 10. We can do that as well, but I think this is easier because this works if you have like log base 4 problems given and other base numbers, which they do. All right. And then we could back up here and then we could FOIL and say that equals 10, get it equal to 0, and that would give us the 2 answers that we would get here. Don't you like the way I can go back and forth on these things and go whoop, 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 and all the writing goes away? It's just magic. So I like, I guess for an overall rule, what I want to put here is if, let's say you've got the, and I'll pick another number here and show you something cool. The log base 4, and I'll pick something easier, of 2x minus 5 equals 1. All right. And then over here, I'll take the log base 4 of 2x minus 5 equals the log base 4 of 1. Now, I always tell my lecture classes, these are 2 entirely different creatures, how you solve these 2 for x. And we've kind of looked at this in the first few examples, but let's look at it on an easier basis. Now, this first one on the left, I would sit there and say, well, this you're going to have to go ahead and rewrite as an exponent because remember, logs are exponents in disguise. All right? And you would get this base 4 raised to the first power gives you what's after the log, 2x minus 5, and then you could solve for x. Whereas over here, and I'm going to look at this, you've got log, same base, equals log, same base, so you just take whatever is after the logs and set them equal. All right, so these are entirely 2 different creatures, and these are how you attack logarithmic equations. Now, you may have to do some other stuff like down here. We had to use the first log rule to rewrite that as multiplication first, but this one fell into the left category. All right, where the first example had log equals log was in the right category, and it works for natural logs as well. Now, I'm not going to leave y'all hanging. Let's solve both of these and see if they both are good. So add 5, because 4 to the first is 4. We get 2x equals 9. Divide by 2, x equals 9 halves. And I believe that will check if you put it back in there. On the one on the right, we'll go ahead and solve. Add 5, 2x equals 6, x equals 3. All right, and that should check as well. So there's just a little overview here. Sometimes I have to stop and just kind of try to simplify things before I get to the really nasty one. No, Yuck, no! Please! No, here we go. One with e in it. All right, so solve this equation. The natural log of e raised to the natural log of x minus the natural log of x minus 3 equals the natural log of 2. Now again, notice here we've got the old rule, and it looks like they love to just beat us over the head with this. If you take the ln of e to any power, it gives you whatever that power is, because remember there's a little base e down here and you can clown face it. All right, so notice that's what they did here. Whenever they have the ln of e to some power, that just dropped right down. So the natural log of e raised to the natural log of x gives you the natural log of x, and then you can go ahead and rewrite the problem. Now, Young, why wouldn't they just write the problem like this here? Now, on a test, ladies and gentlemen, I would just probably give you this right here. And then you would say, aha, well, that is subtraction of log, so I will go ahead and use log rule number 2 on that and rewrite the subtraction of 2 logs as division. And here we go. Which one is this from the previous one? I can't go back because it's not there anymore. If I try to go back and show you those 2 things earlier, but you can rewind the video. This would be the one on the right. You've got ln of something with same base, e equals ln of something. So you can take whatever's after this one, set it equal to whatever's after that one, and solve. All right, you know what's coming next. How do we go from the bottom? Multiply by the LCD. Here we come. We get x equals 2x minus 6. X will come out to be 6. And verify that. I believe it will check. All right, so an overview here, and this is what I was talking about earlier. To solve an exponential or logarithmic equation, let's do an overview of the last few videos. Change the given equation into one of the following forms. Now, of course, A and B have these restrictions on it with the following guidelines. If you have A raised to some power equals B, and we looked at this, and we'll just look at one more here. We'll take 5 to the x power equals 7. Solve by taking logarithms of both sides, because you can't get those bases the same. So here's an overview. So you could take the log or the natural log of both sides and go from there. We've looked at those, all right? The second case is if you have the log base A of some f of x function equals b, then I would use the clown face. So we looked at this one here, the log base, I'll just make some numbers up, 5 of 4x plus 1 equals 2. All right, this is what this is saying, because I know sometimes students will look at that terminology, instructors won't say what that is. I mean, they'll look at this and students will go, what is that? All right, so Young wants to spell it out here. So this one would be a clown face since you don't have the log equals log here. So this one you would just take and slap some colors on it if you want. That base 5 raised to that power gives you what's after there. All right. And then you can solve. Now, I'm not solving all these. We're just reviewing here. The third one, you have log base A of something, f of x equals log base A of something, g of x, some functions. And this is the one here. It looks like this. Some of the things we've been looking at. We might have the log base 7 of 2x minus 3. This is the third one here. Equals the log base 7 of 5x. And whenever that happens, whenever you have log something, same base equals log something, same base, then you can just take whatever's after them, set them equal. So you may have got that one, I don't know. So this one, you could take whatever's after these, set them equal, and solve for x. So these are things to look at as you're attacking exponential and logarithmic equations. Attack logs with exponents, exponents with logs. They undo inverses of each other. And of course, in a more complicated equation, such as the one in the earlier videos, it may be necessary to solve for a raised to the f of x or log base a to the f of x, and then solve the resulting equation using one of the methods above. So you may have, they might throw some log rules in there and stuff, and you'll have to combine some things together before you do it, but it can be done. And always check and make sure none of those logs have negative outcomes. Professor Bob Young, signing off. Keep up the good battle.